In this short video, we'll be discussing how you can calculate the Gibbs free energy change of a given reaction. Now in class we discussed how Gibbs free energy changes can be used to figure out spontaneity of processes at constant pressure. As it turns out, reactions that we do in our synthetic labs are typically done at constant pressure. So the nice thing is we can use Gibbs free energy change as a metric of whether or not this reaction will proceed, whether it's spontaneous to proceed, or whether or not the system's at equilibrium. So in order to do that, we're going to be using two different methods that will get at this Gibbs free energy change. And so either way, we're going to be calculating out the standard Gibbs free energy of a reaction. So the standard Gibbs free energy of a reaction. This is usually shown by delta RG naught. And so what this really is the difference in the Gibbs free energy of products and reactants. Now there's two different ways we can calculate this out. So one method is to use the enthalpy change of a reaction and the entropy change of a reaction to then figure out what the Gibbs free energy change of a reaction is. So using a similar structure to the change in the Gibbs free energy, we're going to just apply it to this of the reaction. So what we can write out is that our Gibbs free energy of a reaction is equal to the enthalpy change of a reaction minus the temperature times the entropy change of a reaction. Now, in class we previously discussed how to calculate both these two terms. Typically you'll need a list of enthalpies of formation or molar entropies for various products and reactants, and you calculate the sum of all those, and you get the total here. So if you have those, say you only have enthalpies and entropies, you can calculate out this reaction Gibbs free energy, or you might just have these totals at your disposal, in which case it's really simple. Now, typically this is not the most common method because, you know, if you have the appendices that have these two pieces of information in it, you can probably have this the Gibbs free energy of formation at your disposal as well. So the other method is that this Gibbs free energy of the reaction can be calculated from the Gibbs free energy of formation of individual components in the reaction. So what we can write then is our Gibbs free energy change of the reaction is equal to the sum of your products with this coefficient V, and then the Gibbs free energy of formation for each individual product. And then for that we're going to subtract the sum of the same thing but for three reactants. And so V here is once again your stoichiometric coefficient. You have your Gibbs free energy of formation for all your reactants. So you sum these two up, you subtract each other, you're going to get out the reaction here. So once again, these two are stoichiometric coefficients. So it's analogous to calculating the enthalpy change of a reaction, where we did the same thing. As it turns out, your Gibbs free energy of formation is 0 for substances in their reference state. And if you recall from doing enthalpies of formation, a reference state is whatever state that allotrope is at given the reaction conditions. So this is really all you need to do to calculate this enthalpy change of the reaction. As it turns out, we kind of discussed this previously, but I want to restate it. If this Gibbs free energy change of the reaction is less than 0, the reaction is spontaneous. If your Gibbs free energy of the reaction is greater than 0, the reverse reaction is spontaneous. And if this Gibbs free energy happens to be equal to 0, you're at equilibrium. So these problems should be straightforward, but it's something that you might want to practice because you never know, it might end up in a homework or on the exam.